Bright Tuty. Every student matters.
Okay, now we are going to learn about multiplication of fractions. Okay, so why is there a need to learn multiplication of fractions? Okay, suppose you have a rectangle. You have one rectangle. Suppose this is a rectangle. Okay, this is the length and this is the breadth. So suppose we are given the length as 7 meter and the breadth as 4 meter, and I ask you the area of this rectangle. What you will do? Length multiplied with breadth. So you will multiply 7 with 4, that will give you 28 square meters. So you can simply answer it. What if I say that the length is 7 whole 1 by 2 and breadth is 3 whole 1 by 2? Here also you can say we will do length into breadth. So 7 whole 1 upon 2 into 3 whole 1 upon 2, converting to the improper fraction, we will get 15 upon 2 multiplied with 3 to the 6 plus 1 is 7. 7 upon 2. Now to solve this, we need to learn multiplication of fractions, right? So for such things where it comes to real life, we need to learn about how do we multiply fractions. So let's start. Just see here, multiplication of a fraction by a whole number first. First of all, we will learn this, a fraction with a whole number. Okay, as you can see here, there are 4 equal parts, out of which 1 is shaded. So I can say this is 1 upon 4. Yes. Similarly, here out of the 4 parts, there are 4 equal parts. Out of these 4 equal parts, 1 is shaded, as you can see. So this also represents 1 upon 4. So 1 upon 4 and 1 upon 4 is what? We can add them. If we add them, what will happen, students? See, if you combine this figure and this figure, you are going to get this figure, right? Or we can get this. Yeah, they're same. So what we will get? Half of it. Are we getting half of it? Right? Half portion out of the complete circle. Complete half like portion is shaded. So half of it is shaded. Can I say that it is 1 by 4 plus 1 by 4? When the denominators are same, I get it as 2 upon 4. Yes, that means 2 parts out of the 4 parts are shaded. As we can see here, 2 parts out of the whole 4 parts are shaded, which is nothing but 1 upon 2. So can I say it as 2 into 1 by 4? 2 times 1 by 4 I got, yes, and which is giving me 2 upon 4. That means we are multiplying these. The numerator will get multiplied with the whole part, right? Okay. Now here, as you can see, this is there, we combine them, we are getting this. This is nothing but 1 upon 4 and 1 upon 4, which was coming as 2 upon 4. Okay, and we cancel it out, we get half. That means half of the portion is shaded here. Clear? Okay, can you think about this one? How many portions are there total equal? As you can count, 1, 2, 3 and 4. Now to represent the fraction, out of the 4 parts, how many is shaded? 1. 1 upon 4, then here 1 upon 4, then here also 1 part out of the 4 part is shaded. So when we add them, we will get 1 plus 1 plus 1 is 3. 3 upon 4. 3 parts out of the 4 parts are shaded. Can I write it as 3 times 1 upon 4? Yes. And actually what we are doing? Multiplying the numerator with the whole part. Quite clear? Let's talk about this one as well. Here, how many parts are there, students? 1, 2, 3, 4, 5, 6, 7, 8 and 9. How many total parts? 9 parts. Out of the 9 parts, how many are shaded? 2 parts of 9 parts are shaded. Here again, as you can see, 2 parts out of the 9 parts are shaded. Here again, 2 parts out of the 9 parts are shaded. If we add them, okay, 2 upon 9, 2 upon 9, denominator is same. Add the numerator, but we will get 6 upon 9. And here also 6 parts are shaded out of the 9 parts, which can also be written as 2 upon 9. It is added how many times? 3 times. So 3 times 2 upon 9. Again 3 into 2 is 6 and we are getting in the denominator 9. So when we multiply a whole number with the fractional part, so the numerator of that fraction will get multiplied with the whole number. Clear? Okay, let us now find out 3 multiplied with 1 upon 2. That means 1 upon 2 is coming 3 times. So how can we write it? We can actually mention 1 upon 2 plus 1 upon 2 plus 1 upon 2. And when you add them, it gives you 3 upon 2. Right. Also, just see 3 upon 3 into 1 upon 2. What is it? 3 upon 2. Then can you tell me this thing if I have 2 upon 3, okay, into 5, how will you do it? Multiply it with the whole part, 10 upon 3, right? Similarly, students, if I have 3 times of, or 3 multiplied with 2 upon 7, so 3 2s are 6, we will get 6 upon 7. Can you tell this one? 4 into 3 upon 5, if we solve it, 4 3s are 12, 12 upon 5 we will get. So this is how we multiply fraction with a whole number. Clear? So what is the conclusion here? The conclusion is to multiply a whole number, okay? We are multiplying a whole number with the proper or an improper function, or I say the fraction. Then what do? We multiply the whole number with the numerator. That's what we have been doing in the previous examples. We are multiplying the whole number with the numerator of that fraction and we keep the denominator same. Okay, so whenever we are going to multiply, students, a whole number with the fraction, the whole number will get multiplied with the numerator of that fraction and we will keep the denominator same, right? Okay, so let us solve this. They're saying we have to multiply these, and if we get the answer as an improper one, then we have to express it as a mixed fraction. That we know how to do it. Let's practice this one. In the first part, it is 2 upon 7 into 3. Okay, so we know I'll multiply 2 with 3, that is 6, and denominator will be kept as same. Is this a proper or improper fraction? Think about, the numerator is smaller in this case and than the denominator. So it is a proper fraction. Okay. In the B part, where we have 9 upon 7 into 6. So again, I'll multiply 9 with 6. 9 with 6 is 54 upon 7. So what is it? Is this proper or improper? You can easily see that the numerator is greater here, correct, than the denominator. So it is improper. We can divide it. So let us try to divide 54 with 7. 7 sevens are 49. We can subtract it now. Now 14 minus 9. What does it give you? 5. Correct. So we are left with 5 as the denominator. So what will be there here? 7 is the question, remainder is 5 and 7 is the denominator. Yeah. In the C part, we have 3 into 1 upon 8. So it will be 3 upon 8 only and it is a proper fraction. As we can see, the numerator is smaller than the denominator. In the D part, what do we have? 13 upon 11 into 6. So multiply 13 with 6. 6 into 3 is 18. 1 will be the carry. 6 ones are 6 and 7. 13 6 are 78. Divided by 11. 11 sevens are 77. 1 will be the remainder and 11 is the divisor. So we have expressed it as a mixed fraction. Clear? Okay, now we have to represent it pictorially. It is 2 times of 2 upon 5. That means 2 upon 5 plus 2 upon 5 we have to show. Okay, so you can consider this figure. Here see, out of the 5 parts, there will be 5 in total. Denominator is 5. Okay, so I have shaded 2 parts, this one and this one. So 2 part out of 5 parts. Then again we are adding it with 2 parts out of 5 parts. So in total we have 1, 2, 3, 4. 4 parts out of the 5 parts are shaded. So when you add 2 upon 5 plus 2 upon 5, you get 4 upon 5. Right? So this is how we represent it pictorially. You can use a circle also, students, and can make 5 equal parts in that. Yes, and then you can, try to shade 2 out of these, out of the 5, and then again you can have the similar circle and you will get the answer as 4 upon 5. That way also you can show. Okay, then we have this one, we have to solve it. So 5 into, first of all, you are going to convert this mixed fraction into the improper one to multiply a mixed fraction with the whole number. Let's multiply 7 2s are 14. 14 plus 3 is 17. Right, now what we will have, 17 and 5 you are going to multiply, denominator will remain same. That's only you need to do. In the second case, when you have 1 upon 4 upon 1 whole 4 upon 9, let's convert this to the improper one. 9 ones are 9 and 4 is 13. 13 upon 9 into 6. Again you will multiply 13 and 6, that would be 78 divided by 9. Yes, you can do that. And here also 17 5. 85 upon 7. So these are the answers that we are going to get. So here we are going to start the operation of. Of is generally multiplication only. So just see this one. There are 2 parts out of which one is shaded. If I talk of the shaded part, students, what is it? It is half of 1. Can I say this? Yes, it is half of 1. And this also I can say half of 1. Correct? Half of 1 and half of 1. And what is this? This is what? Nothing but 2 halves. I can say this half and this half, they combine together to form this one, the complete portion. So this is what they together will represent, half of 2. Right? These 2. Correct. So of means multiplication. Of is multiplication. So what do we get, beta? We get 1. So we are getting the whole part using this. Okay, let's consider one more figure. And first of all, we will solve this and then we will consider one more. As you can see, half of 10. Now you know of means multiplication. So half of 10 means you can cancel it out. It will be 5. 1 upon 4 of means multiplication. You will multiply. It will be 4. Then 2 upon 5 of 125. 5 5s are 25. 2 into 5 is 10. So this way you are going to solve such questions. Right? So here we have, okay, one last question. And before that, I wanted you to observe one figure. Just see in that case only. If I have the same figure where we were representing the half, so I am just roughly drawing it. This one is shaded. Similarly, I have the again second part where also half of it is shaded. Okay, and again one more I have where also one more is shaded. So this is what? Half of 1. This is half of 1. And this is half of 1. Together they will represent half of 3. That means what? Half of 3. 3 upon 2. That means just see here. So if we combine them, 3 upon 2 is nothing but 1 whole 1 upon 2. That means 1 complete and half. Right? This you will form. 1 complete this and 1 half of it will be formed. So this I wanted you to notice. And here we have the last question for today. In a class, total 40 students are there. Okay, 1 by 5 of total of means multiplication. 1 by 5 of the total number of students like to study English. So can you calculate how many likes to study English? Yes, we will do 1 upon 5 of 40. 5 8s are 40. 8 students out of 40 students, they like to study English. Then 2 by 5 of the total number of students study mathematics. Okay, 2 by 5 of total. So 2 by 5 of means multiplication, total is 40. 5 8s are 40. 2 8s are 16. They learn mathematics better. Yeah, they love to study, they like to study mathematics. And remaining, okay, so 8 students are learning English, 16 are studying mathematics. They're asking how many students, the remaining are the ones who like to study science. So how many are these? Now we have already answered the first question, how many students like to study English, that is 8. The second is how many students like to study mathematics, that is 16. And out of a total strength of 40 students, 8 students likes English, 16 students likes math. So total there are 24. Okay, now if there are 24 students who like to study maths and then other are there which like to study English, the rest students like to study science. So we can subtract from 40 24. 10 minus 4 is 6. 3 minus 2 is 1. So how many are left? 16 students are left who like to study science. So what we have calculated is the number of students out of 40 which like to study science. Here it is 16. But what we have to calculate, not the number of students who like to study science, but the fraction of students. Fraction of total number of students. So out of 40 students, there are 16 who likes to study science. So the fraction, the required fraction would be 16 upon 40. You can cancel it also. It will be, if we cancel with 8, it is going to be 2 upon 5. So this is in the simplest form. So the right answer for the third part is 2 upon 5. The fraction of total number of students who like to study science is 2 upon 5.